Hi guys, Ban here. The thing I'm doing now is not really planned. I just thought it might be interesting for one or two of you people. The thing is, I've been playing around with Vectorblade again. This is the shooter I'm programming at the moment. And in the beginning stages of the game, I had so much space available since I wanted to do a 64 cartridge game that I didn't really care about, well, space, memory. And the fighter especially, I'm just going to start it to show it to you, is a huge waste of memory. I'm going to show you what I mean with that. At some stage it will have compiled. It's compiling Vectorblade, you see it. And if I one moment, I think I've got Undying switched on, so I can show you what I want. Main one. Undying must be off, otherwise I cannot die. Just a sec. What I'm going to show you is an explosion of the fighter when it dies. This is such a huge waste of memory, and this is what is following up with this. This is a fighter down here. There are the enemies. The enemies explode too. You see that? It's a silly little explosion, and bam! There, the fighter explodes. The fighter explosion you just saw is realized doing vector lists. Fighter explode. These are this here, and the vector list is actually the fighter exploding in different patterns. These 12 vector lists that make up the explosion take up about 2K of memory. This is an absolutely waste. Additionally, there is a debris animation list. This is for the enemies. This is another 500 bytes or something like that, wasted. And my plan is to get rid of these vector lists and do other kinds of explosions, so I can free some memory, which I now really need. And this led to the following thing I'm going to show you. I've got here a demonstration program for different explosions. I'll show you the most simple explosion I could think of. These are Mindstorm explosions. The memory imprint of Mindstorm explosions, if you use them in your own games, is absolutely low. This is the code for the explosion. It's so small because you can actually reuse the Mindstorm code. This above here is a Mindstorm explosion pattern. The pattern actually is a vector list, and in Mindstorm there's a function that moves and draws vectors, very similar to the BIOS but slightly different. Anyhow, with this code you can well, do one explosion. I wrote a wrapper for my explosion functions, so I can just add and destroy them. Just a few words. X count is a count of explosions. I can do many more explosions. So now if I compile it again, there are 10 explosions. Come on. Still looks okay, I think. The thing with Mindstorm explosions, they are all the same. If you look at them, they're exactly the same. It's not much variation, and using the Mindstorm code actually is not really fast. You have to do a couple of subroutine calls, but the memory imprint is fantastic. Second explosion type I did was the Mindstorm explosion, a little bit enhanced with my own functions. It's a little bit faster. Now the general speed average is about 21,000 cycles for 10 explosions. With little enhanced versions, it's a little bit faster. Slightly, about 1K, 1.5K cycles faster. The difference actually is this here. This is... Oh! Okay, one moment. There are 20 knobs. Perhaps I should remove them. Might be still a little bit faster then. Oh, tiny little bit. They are. After the actual thing. Maybe. Yeah, 500 cycles faster. This code here is actually the drawing functions, which I'm not reusing from Mindstorm, but doing my own drawing function. This is a tiny little bit faster, as you see, but the explosions are still boring, so to say, and the Mindstorm explosion pattern is still reused. So I thought about other kinds of explosions. The next explosion is, I call dots from middle point. This is similar to some explosions of release. You will see the sort of release functions. This is quite slow actually, as you see the cycle imprint here is a little bit larger. The thing is, it still doesn't use much memory, because here also I'm reusing BIOS stuff. Within the BIOS, sorry, excuse me. Within the BIOS there are I have to go to the BIOS to show you. Move to the nope. Man, oh, doesn't matter. I think it's correct. This way I can very... Actually, I think I implemented if I shift click. One moment. This thing. Yes. If you shift click the sun, you go to the BIOS and can look it up. Well, forgot, but now I remember. Anyway, within the BIOS, somewhere, written it here, it's FC60. FC60. This thing here is actually a sign value table. These are 32 values of sinus values, and it's half sinus. Going to show you what I mean with that. I didn't prepare this. You see that? Come on, new, some image, doesn't matter. I just want to draw some thing, and not with this huge pen. Oh man. So this is a coordinate system, not very well coordinated, and the sinus goes something like this. Okay, you know what I mean. Anyway, the data in the BIOS is from here to here, so the first half of the sinus. And actually with this definition you can get all values of sinus and cosinus. This here is 180 degrees, 180. This is 90 degrees. And if you want to get the second half, just have to negate these values and you have the second half of the sinus. If you want to have a cosinus, you just have to add 90 degrees, or in respect to this data, $10. Then you have got the cosinus, and then you cosinus, and so on. So with swapping 90 degrees, 180 degrees, and negating the values, with this little data you get all sinus and cosinus values that you can imagine, or that there are actually. And well, it represents a circle in the end with 360 degrees, and there are 64 values for a full sinus or cosinus that you can gather from these values. So 60, the numbers from 0 to 63 represent the angles from 0 to 360. Okay, you have to think about that probably, but I told you so. Anyway, what I did was write a little function, get circle coordinates. It uses the BIOS sinus table and just looks if it's greater than 180. Is this cosinus? Is a sinus? If so, in the second half you have to negate the values. Blah blah blah. Anyway, what you do is load register B with an angle from 0 to 63, and what you get back in register D are sinus cosinus values of the representing angle, and this thing you can easily draw these explosions. So this is a little helper function to get coordinates, and the actual explosion function then looks, well, this is a whole function, these, I don't know, 40 lines or so. Well, it is quite slow, since you always have to get the coordinates for each angle that you draw, but well, it's working okay if you just do the one or the other explosion. Actually, you can also do firework with it. I'm thinking about doing using it for the perfect score of a bonus challenge stage, and use this one as a fireworks display. Then I've got version 2a. This looks exactly the same, but is again a little bit faster. Now the average is about 33k, and I'm doing the type 2a. I'm resetting. This looks exactly the same, but it's again, I don't know, 2k faster. This is because I removed the call to the BIOS sign data, and this is exact same data, more or less, generated within Vide, 64 steps for 360 degrees angles. These are sinus cosinus values. I think sinus cosinus minus sinus values, but anyway, if you just want to draw a circle, it doesn't really matter. And this one, the rest is exactly the same. It just replaces the subroutine with a table of circle coordinates. 10 explosions are, well, always heavy, and you also have the string here. The string alone, I don't know how many thousand cycles it takes. So this was a third or fourth explosion function that I did, the fourth already. Then the next one, which one was that? I can't even remember. Dots from middle point, rotation. I just started. I have to look what it is. This is again nearly the same. This is enhanced version, I think, of the number 2 or number. Which one is it? It uses a subroutine. So I didn't much care if I use a subroutine or not. These were just examples that I wanted to do. Anyway, this is again dots from the middle, and these dots are also rotating within themselves. Also, I got this idea more or less from release. I don't know. It doesn't really look much like an explosion. Perhaps it does if you do 2 of them on the same spot or so. It's just examples that I did that, well, could be done easily. This is the code for this explosion. Excuse me again. What was the next one? Line middle point rod. Okay, this is, I didn't draw dots, but lines from the middle point, because I thought, well, it might look a little bit more debris-ish if I do lines from the middle and do not do dots. This is from this actually is, I think, a little bit faster even than the last one, because the dots use a dot well, and these lines I draw while going back to the center and just using a shift which is not completely finished. This one here, the four set bits for the shift register do about 8 cycles of line width. This one is stupid. Test. With this you can change line length that go to the middle point and just show you the longer lines. It's there, the lines are a little bit longer. You can even, well, if you want to, have full lines to the middle, but that doesn't look very explosion machine, I think. Oh, looks starry. It's starry night. Perhaps I should use this as fireworks. Well, I don't know. Okay, explosion type 4 that was. Then I've got objects. I think, well, let's look at it again. Do I have a define here? No, sorry. Then the explosion number 6, or whatever you call explosion. Oh, I did a double click somewhere. This is an explosion which spreads debris. Debris in the sense of these are little vector objects. You see the cycle impact is absolutely huge. It doubled. Well, you do not do 10 explosions at once, so that doesn't really matter. Or it does certainly matter, but I do a little bit fewer explosions, then it's not quite so slow. So you can see, I pause it. Here you can see there are different kinds of objects that explode from the center. There's a triangle, there's lines and so on. They are defined down here. These are the different objects, squares, lines and so on, and per more or less random they are determined from this list and spread from the middle. For my taste, this also looks a little bit too regular because they are, well, circular explosions. Well, physically that might even be correct, more or less, but well, it's an experiment. All these are experiments, and all of these use way less memory imprint than the explosions I've got now in Vectorblade. Last one for now I did was also these objects, but not quite so regular exploding. So they vary in the distance from the middle point a little bit. You see that? These are not real circles anymore, but slightly deformed. Perhaps I do just one explosion, then you might see that clearer. Here you see this is definitely not a circle. These are all a bit different from the center. Here you see that quite good. Actually, the number of objects and the number of things per circle, this is determined by how many dots per circle. This is a divisor of 63. If I do, I don't know, 4, there are way more objects again. I wouldn't call that way more. Let's do some more. Now these are more here. See, well, it does look actually explosionish right now. At least until it reaches a certain size. Then you can also configure how fast the explosion will be. One is quite a slow explosion. Well, it's more a drift, I think, than an explosion. 3 is quite fast. You can also switch for the last two explosion type 1, 5 and 6. The inner rotation on and off with this do rotate. Where it looks spirally, and you can change the speed of the rotation also, the inner rotation that is, and well, it looks confusing after a while, I think. If I do that the other way around, I think I could do a black hole or something like that. Let's do 2 of them, might look better. Oh, that's why I should do a black hole. Black hole game with these functions. Okay, anyway, these are my current experiments with explosions. I do not know what I finally decide to take for Vectorblade. Maybe something completely different. But I need to get the memory, and these explosions I did were just, well, shortcuts I did at the very beginning, and I can't stand them anymore. So this is what I'm thinking about the last, oh well, actually quite a few days now, and I can't get to grips with what I really want to do with the explosions, because they should still be performant. They should have really low memory imprint, because and they should be fast, because there might be many explosions on the screen at one time, where if I shoot 20 aliens or something like that. Anyway, this is what I'm thinking about now, and I will do a blog entry for this where I will post this video, and if you're interested, I will also share this explosion project, so you can try things out of yourself if you want to. The main file will be explosion.asm, and the different explosions can be commented in and out here and configured in the upper section. This is a complete main code. Okay, that's all I wanted to say for today, and well, bye.